Welcome. Wonderful weather we're having, everyone. I hope you enjoy joining me today as we have the pleasure of learning about Professor Heichal. Last semester, I took Professor Heichal's class, CE 325, Structural Analysis. I enjoyed the class and getting to know her, and I'm excited to interview her.
Okay, hi Gatli. Thank you so much for having me. I'm definitely happy to be part of the podcast. I think that's a great idea, and thank you so much for inviting me.
Okay, so starting off with some background questions. What is your job title, and where did you get your degrees?
I'm an associate professor in the Department of Civil Construction and Environmental Engineering. I am part of the Structural Engineering and Mechanics group here, also part of two other groups that relate to my research. My degree is in civil engineering from the University of Illinois Urbana-Champaign.
And did you get both your undergraduate, graduate, and PhD there?
Actually, no. I'm originally from Syria. I did my undergraduate degree there at Tishrin University in Latakia. That's a coastal city in Syria. And then I came to the U.S. for a master's degree, which I did at the University of Illinois. And I followed up with a PhD degree at the same university. My original plan was to do a 2-year degree and go back home, but then I enjoyed the program so much that I stuck around for a PhD, and then here we go. Here we are today.
Final background question. How long have you been teaching at NC State?
This is my second year.
Oh, okay.
So
I didn't realize you're brand new. Okay.
Yes, brand new. Started in fall 2022.
Okay, so my next question is, when you were a child, what did you want to be when you grew up?
That's a very good question. So
I think when I think about this, it's like I would imagine most professors they're not like, oh, I want to be a structural engineer when I grow up.
Yep.
It's pretty specific.
Yeah. For me, civil engineering was a discovery that I made later, much later in my career before I got my high school degree. When I was a kid, I actually wanted to be an astronaut. That was my first thought.
That one's pretty common. It's pretty common. Still science related though.
Science related. There was a brief period of time where I actually wanted to be in business, and that was influenced by my dad. My dad had an advertising company, and as I grew up and I learned a little bit more about what he did, I was intrigued and I wanted to be part of it, as I guess part of the family business. But I think what attracted me to that was similar to what attracted me to academia, is just communication with people, meeting, and especially advertising, is how do you promote your product. And but then that was also relatively short-lived. I think as I advanced in my high school, especially as I approached high school, I enjoyed math a lot, so that switched to I wanted to be a math teacher. And shortly afterwards I was introduced to physics, which for me was clinched the deal. I think I want to be in something that had to do with math and physics. I wasn't quite sure what that looked like, but then as I came to the end of my high school career, that's when I landed on engineering, because that was for me the field that balanced what I liked about math and physics with also some applications.
Yeah. I find that pretty much everything we do in engineering is like physics 1, that like the intro class, but you just find different applications and go more in depth on all of those.
Exactly.
So the next question is, were you always set on going to college, or did you consider some alternatives?
No, it was always college for me.
And do both of your parents have college degrees?
Yes, they do. Yes.
Okay, so I guess education was a big part of your household?
It was. And my mom actually was one of very few people to get an undergraduate degree at her time in Syria. And my dad had a PhD in economics, so growing up, it was always education was important, and it was very important that you did well in school, and there was a lot of encouragement
Yeah.
throughout my childhood. Yeah.
So how did you have trouble choosing which undergraduate degree you were going to get? How did you decide to go with civil?
Civil. Well, it was a combination of two things. First of all, the academic program or the academic admission process in Syria is very different compared to the US. And what happens there is you take this national level exam, and based on your score on that exam, it determines which field you get into.
Really? Wow, that's interesting.
It's a very stressful exam because 1 point, one way or another, could change things quite a bit for you.
Yeah.
And as I mentioned, I knew I wanted something with math and physics, but I wasn't quite clear about what that was. And it was up to my last year in high school, when I was preparing to take that exam, that I had to start thinking really seriously, okay, what is my college degree is going to look like?
Yeah.
At the time, if you were doing well in school, the general idea is that if you do well, then you're going to be a doctor, you're going to go into medicine. And for me, that was a big no, because biology is not my strongest suit. I definitely wasn't, didn't do well there. I didn't enjoy it as much. And so I wanted to do something with, again, math and physics. And I was, intrigued by buildings and bridges. But in my very uninformed background, I thought that was architecture. So I actually thought that I was going to apply to the architectural program. But then when I did that, final, national exam, and I was looking at the areas that I was able to get into, I saw civil engineering, and well, okay, what is civil engineering and how is that different compared to architecture? And that's where I realized that this is what I wanted to be. So I guess I was looking for civil engineering. I just didn't realize it was called civil engineering.
Yeah, I have a pretty similar story. Like, I wanted to be an architect when I was a kid, but I was very into the math side, so I thought civil was like a nice merger of the two.
Yes, exactly. You get to do the fun part, right? You get to make these beautiful structures work, stand up.
Yeah, exactly. I love that.
Yeah.
So when you went from undergraduate to graduate school, was it like a easy decision to get a civil engineering master's? Because I know some people, they have different master's and undergrad degrees. Or were you knew it was going to be civil?
It was, for me, I don't think I ever considered doing a different master's degree, because at the time what was driving me for graduate school was structural analysis, and I wanted to understand how structures behave, how you can predict that, and I guess was focused primarily on structures. Now, that said, I realized as I went down the line that whatever we learned for structural engineering can apply to other areas as well. But my focus was always on structures.
And how did so you went to undergraduate school in Syria.
Yeah.
And how did you choose to study in the U.S. versus staying in Syria, or perhaps going to like England or France or somewhere?
Yeah.
Did you apply to other options?
I did. So after I finished my undergraduate degree, I actually signed up for a master's degree in Syria. That said, at public universities in Syria, there is not much opportunities for funding, for research, for projects that were externally funded. So the options for what you could work on were relatively limited. And that, prompted my decision to start looking into study abroad. So how I landed on the US is a bit of an interesting story. For me, it was always the top destination as far as where I would, this would be my number one choice. This is where I would love to go.
Is that because of funding, or you just want to live in the U.S.?
No, just the appeal of the programs in the U.S.
Okay. Like their rankings and things like that?
Yeah. And the the variety of courses that you could take. If you look at European institutions, there isn't as much focus on course taking in your master's degree or your PhD degree in some places at all.
Yeah.
But I really wanted to be in the US because, again, best universities, very diverse programs. There's a lot of different things that you could do. And however, I was restricted by funding. So I didn't have any means to support myself for a graduate program. And therefore, I was looking for scholarships. Now, in Syria, the professors that were teaching me at my university were professors that got their degrees mostly in Europe. I didn't have a single professor who had their degree in the US. And therefore, I was initially a little bit more oriented towards Europe because asking around, people were giving me suggestions for places I could apply for scholarships. And I, didn't hear of any option to apply to come to the US. What happened, again, a bit of a long story, but I was at the British Council, basically the British Culture Center in Damascus, asking for scholarships to the UK. And there was one that I could have applied to, and they said that required a TOEFL exam. That's a English proficiency exam for international students. And there was another exam that you could take called the IELTS exam, which is the British version. Now, I had heard of TOEFL, I hadn't heard of IELTS, so I asked where could I potentially look into taking the TOEFL exam, and they directed me to the American Cultural Center. And that's where I saw an announcement for a Fulbright scholarship.
Oh, okay.
So I hadn't, I didn't have any knowledge of that Fulbright scholarship ahead of time, but I saw that day. The deadline was in a month or so. So I scrambled to put the application together, but that ended up working well. So I got the scholarship, and that's how I ended up coming to the U.S.
And so with that scholarship, that could be used at any university that you got accepted to?
Well, not quite. So you had to, because the Fulbright program was funding your study, they had a role in selecting the programs that you end up going to. That changes from country to country. Fulbright is an international scholarship that supports students from different countries to come to the U.S., but it also supports students from the U.S. to go study abroad. So the process for Syria was that you gave them your preferences in terms of universities, and they end up deciding which one you end up going to. And that had a lot to do with how much funding is going to be required. And a big part of it is if you receive any funding offers from the university itself.
So who does the applying to the university? Is it you or is it the... Okay.
Yeah. They helped definitely with putting together the applications and everything.
Interesting.
But for me, I had 4 choices. University of Illinois was my top choice. And it worked out well because I ended up getting a tuition waiver from the University of Illinois, which made it, so that it was very easy for Fulbright to support me going there.
And so if you don't have to pay tuition, is that Fulbright scholarship going to like housing or?
Yes. Yes. So they would pay you a monthly allowance that will cover your housing and any other like maintenance, like living expenses, and they pay for books and things like that. So.
Okay.
Yeah.
Interesting. So after you went through your master's program and then you went to PhD, so going into your PhD, had you already decided that you wanted to become a professor, or were you considering going into the industry?
Yeah, I had a preference for a university professor job. I was going to apply to all possible career opportunities, including industry. But I had some experiences with both teaching and research that made me realize that I would really enjoy being in academia as a professor. So that's a bit of a long story. It was multiple things along the way that made me realize that. And it started with my undergraduate thesis. So as part of the program at Tishrin University, we had to work on a senior project, and that senior project could be a research project in any of the areas that you're interested in, or potentially a design project. And for me at the time, I had taken a couple of structural analysis courses that I enjoyed very much. So I approached my structural analysis professor to see if I could use this senior thesis opportunity to learn more about the topic. And I had also taken a computer programming course that I also enjoyed very much. And at the time, he was working with a group of students to develop a structural analysis program, like a piece of software for the analysis of trusses, beams, and frames. And he offered me the opportunity to develop that program further. And the idea was to see if we could implement some of the user input interfaces that were starting to become available with Windows into the program, and maybe enable the users to say like draw a frame to be able to analyze it and add some visual aids and visual tools, and also maybe add some additional analysis capabilities like free vibration analysis or buckling analysis. And for me, that was a very exciting topic to work on, because it was a combination of programming with some new tools, right? And also, digging a bit deeper and learning more about the topic that I had, started to realize how much I enjoyed it. So that was basically my senior thesis. And keep in mind that this was Syria about 20 years ago. So there were a lot of challenges in terms of availability of resources. So we didn't have access to a lot of, say, research papers or books. And also computing resources were very limited. So we had about 20 computers that we could use in the university, and it was old software. It wasn't even Windows-based. And, to be able to write the program, I had to basically learn the programming language on my own. We used Visual Basic at the time. But for me, that was part of the fun of the project. Again, it was a very challenging project, but I also learned a lot, both in terms of structural analysis, the topic, but also in terms of programming skills. And for me, the discovery process was a big part of the fun, finding out information, learning how to, translate that information and into an actual product. So by the end of that project, I was even more excited about structural analysis. I had learned more, and so I even, for me, that made me realize that, yes, this is something that I would love to even look even further into further. And I also enjoyed the research process. And we ended up with a very nice program, software, that the university decided to use in the instruction of structural analysis. So again, we didn't have access to software like, SAP or any other commercial software. So this was a very nice, like, home developed tool that they could use in the teaching of the class. And I was hired as a teaching assistant, and I was tasked with basically conducting the lab sessions to teach students how to use the software. So that turned out to be another really wonderful experience for me, because, obviously it was my code. I had written the code, so it was really fun to teach it. But also I discovered that I really kind of enjoyed the interaction with the students, teaching the class, helping students, answer questions. And the combination of the research experience with the teaching experience made me decide that this is definitely a career path that I would love to explore. So it was with that, frame of mind that I applied for the Fulbright Scholarship. And my thought at the time was that I would, go to the US, get my master's degree, and come back, work at the university for a little bit until I could secure an opportunity to do a PhD degree, and then hopefully come back and teach, be a professor at the university. So I started my program at the University of Illinois, and you take classes. Obviously, for me, it was an eye-opening experience. So I learned a lot more about the structural engineering profession and all of the things you could potentially explore as a career. But I also took some classes that for me was provided another turning point. So one class that I took in my first semester was a structural mechanics course, basically the three-dimensional version of structural analysis. And I just loved that class. I loved, learning more about three-dimensional, behavior. And that class ended with some numerical tools to be able to analyze structures in 3D. And I really enjoyed it, so I decided to make this as my, or pursue this as my as my master's thesis. And my thesis was to look at developing some methods to analyze problems that involve contact interfaces. And so again, another research experience, very, very enjoyable. The more I learned about analysis, either structural analysis or computational mechanics, the more I realized that this is a field that has a wide range of applications that applies to different fields like mechanical, civil, biomechanical, and I hoped to be able to pursue the topic for a PhD. So that was like at the end of my master's degree. This is where I was. I was hoping that maybe I could potentially find a PhD degree and in computational mechanics. And I was, if that didn't work, obviously I was going to apply for other types of jobs. But I was thrilled to get a position at the University of Illinois, PhD for a PhD position with my advisor that I worked with for my master's thesis. And what made it even better was that the job came also with a teaching assistant position, where I was the teaching assistant for the structural mechanics course that I took at Illinois. And the combination of the PhD dissertation research and the teaching experience, that basically sealed the deal. At that point, there was really no turning back. I really wanted to be a university professor. So the moral of the story is actually, these experiences, undergraduate research, maybe undergraduate teaching, master's research, these can be really eye-opening experiences that can help you explore different areas, explore research, and who knows, that could potentially turn into a career track like it did with me.
Where did you work after you got your PhD? Where was the first job that you were hired?
I was at Purdue University as a professor for about 10 years. Yeah.
And you start off as an assistant professor,
yes.
Right?
Yes.
And how were those first couple of years? Was it hard to transition, or
was?
What was if you're an assistant, do you have like different levels of research, like the amount of, I guess, research funding increases as your title increases?
That's a very good question. So when you're hired in any academic position, you get some initial funding from the university. They call it a startup package. But the goal of that is startup, meaning just to get you started in hiring, students and getting some research work going. But ultimately, you are responsible for bringing in funding from outside sources.
Yes.
So that's the same regardless of what level you're at. So assistant, associate, or full professor, you are still, applying to get your funding from sources like National Science Foundation or, Department of Transportation, or there are varying places where you can apply depending on your research focus. So going back to your question about whether the transition was hard, that was for me the steepest learning curve.
Oh, For between undergrad, graduate, and professor,
Yeah.
and PhD, that was the steepest.
That was
Wow.
the steepest, going from PhD
I wouldn't have
to
expected
professor.
that.
Yes.
So, what was more difficult about it?
So there were a few things. The first one was I went directly from a PhD to an assistant professor position, which was great, but it's not what happens often. Often you get a year or two as a postdoctoral associate. So with postdoctoral associate, you get some experience in writing your own research grant applications. You get a little bit more autonomy on your research program. So there's it's considered a training period for being a professor. Now, in my case, I was very lucky that I got a position right away out of grad school, but also that made it a challenge because I had no experience whatsoever in writing grants, all of that. So I had to learn that basically on the job, and it was definitely a challenge. So if, for anybody who was considering doing a PhD and getting into academic position, my recommendation is at least ask your advisor to get some role in writing grant proposals before you graduate, because that's an experience that would have been very helpful to me if I had that. And then there's this sudden shift from one day you're the student and you are helping maybe teach, but you're not the main instructor of the course, to you are now responsible for everything. So as a TA, you get to play the good guy, right?
Yeah.
Because you're helping, but you're not responsible for the content. But then as the instructor, you are the one who's responsible for making sure that, everything goes well in terms of, planning and delivery and logistics and all of that. So there was a bit of an adjustment period there, and especially in your first year or two, as you're preparing your material, your class notes, and all of that, that takes quite a lot of time, especially the first time you do it. But it's fun. It was a fun challenge, and part of it was discovering what works and what does not work.
Yeah, definitely.
And it's definitely something that was a fun challenge for me.
So, like, currently, how would you say you split your time between teaching and planning for classes and research and then writing grant proposals? What would you give, like, a proportion of your time?
That varies, but I think on average, I say maybe a third of my time goes to teaching. And that's in my second year. In my first year, that portion was a lot higher because you're preparing your class notes and all of that. So now that I have material that I can use again from last year, that is about 30%. And then I think the rest of it is split between writing grants and other responsibilities, like you're meeting with your graduate students, meetings in the department, service activities, and other things that just come up, I guess, as part of your daily life. But that, I think, is about on average. Now, there are times when you're close to grant deadline applications, for example, grant application deadlines, then that shift goes much higher on the grant side. And there are times when you're teaching and there's an exam coming up and you need to grade, so again, that takes more time on your teaching side.
Okay, shifting more into the research questions. So what is still unknown in your field, and what unknowns do you personally most want to know the answers to?
That's a very wide open question, and I love that I'm in a field that has been so interesting to discover, and at the same time it has opened a lot of doors for discovery in the future. So my work is in the field that we call computational mechanics, and the idea is we want to be able to build computer models for systems like structures that we cannot necessarily fully test in the lab. So if you think about like a large building, high-rise building under seismic loading, you cannot go into the lab and test it at full scale. We can test pieces of it, but so being able to translate that very complex three-dimensional behavior of a structure to something that you can model on a computer is a very interesting combination of mathematics, some programming, and obviously a lot of physics. But that involves making a lot of assumptions about how you're going to model that system. So the structural analysis class that we had was looking at some of these methods for skeletal structures like frames and beams, right? But obviously, if you move into three-dimensional structures, that becomes a lot more complex. Now, my focus in particular is on problems that involve interfaces. So anytime you have two domains that interact through a surface, if you think, for example, of materials like reinforced concrete, right? You have the steel and the concrete that have to talk to each other through that interface. You have materials that are composite materials in general, or even larger scale interfaces, like how the structure talks to the soil. I know we are in structures, we don't really think too much of the soil, but ultimately that has to get transfer the load, right, through that interface. So it turns out that there's a lot of problems with modeling these types of problems. The methods that we have right now don't work very well for these types of interfaces, and we lose a lot of accuracy in doing so, which is an issue because interfaces is where we look for failure mechanisms and where we rely on the interface to transfer the load. So it's very important to model that properly.
Yeah.
And therefore, that's where my work has been. How do you improve models for problems that involve interfaces? How do you leverage that to design new materials, new composites, composites that use different types of components that are maybe more sustainable or that are maybe better optimized for behavior in a specific way? And how do you use that knowledge to prevent against maybe these natural disasters? If you can model a soil structure interaction problem under seismic loading, that will help you prepare much better for designing the structure under extreme loading events. So it's a field that has still a lot of unanswered questions. We are still working on different methods that potentially help solve these problems, but this is a field that also sets the stage for a lot of very nice discoveries for new materials and new types of structures in the future.
On a related note, I think this is a good question. If you had an unlimited budget to produce one paper, what experiment or research or models would you try and create? How would you use that unlimited budget?
I would definitely want to develop a universal computational model for all types of interfaces at different scales. So if you think about, materials that have scales that at the nanoscale, for example, versus the mesoscale as you go up into the structural level, if we can develop a model that can incorporate all of these scales at the same time, I think we have a powerful tool that we can use to design all types of structures for all types of applications. So that would be kind of what I would love to be able to do. There's a lot of similarities in different types of interface problems that I think tend themselves to these types of approaches, but I don't think we have quite figured it out yet. And there's a lot of focus these days about machine learning and all of that. So I am still exploring machine learning. I'm still not 100% convinced that this is the answer to everything, because I don't think anything is, but these are things that could potentially we can look into leveraging more, and in order to again achieve better design and also explore new concepts like design of structures in space. I mean, I've seen a lot of projects on what happens if we want to live on Mars, so these are not things that we can really test in the lab, and therefore simulation can be very helpful in that regard.
That actually, combining the different scales, that reminds me of in the movie Moana, the Disney movie.
Yes.
They had prior to that movie, they had two good models for like simulating water. They had like a sort of an open ocean one where it was like big scale, and then they had like a model for sort of like splashing water, but like it was very small scale. And one of the innovations in that movie is that they combine them
Exactly.
to make a more realistic simulation.
Exactly.
I'm interested to hear more about the AI. I think, especially in the last 2 years, well, probably in the last 10 years, a lot of people have been talking about AI, but it has been really, it's been more intangible up until the last 2 years.
Yes.
And then we've really seen those, like, things that just blow your mind, like, how is this possible? So I'm curious what you think about how AI is going to change research, and also do you think that AI will I'm not sure what's the best word to use, but do you think it will, like, replace a lot of either the work or jobs in I guess engineering as a whole?
That's a very interesting question too, and there's different angles where you can think about that. First of all, I think the methods behind AI and machine learning, for example, is one of them, have been around for a while. So I don't think we have made any discoveries in terms of, okay, now we can use this new approach to solve this problem. The methods have been there for a while. It's just that we didn't have the computational power to leverage them, and we didn't have the data to leverage them. So AI is, or machine learning in general, and these are two terms that are different, but I think we think of machine learning as how we train a machine to learn what we could potentially be available through data sets. And now that we have so much data in some fields, then we can train those algorithms to recognize trends and therefore to model things that are way too complex for the methods that we currently know. So I guess the shift has happened because there's a lot of data, and it's data that's collected through different sources. If you think like weather data, information data, right? There's a lot of things that are now, collection devices, right? Now, that said, we have to be very careful. So I draw some similarities between the big boom in AI right now and the boom that happened in computational mechanics in my field. If you go back like 50 years ago, when computers start to become more easily accessible and computer power became more accessible, and now we can model things rather than have to go back in the lab and test them or use some very simplified analytical methods to solve them. And what happened there is computational methods didn't replace testing. They didn't replace analytical methods. They complemented them. So now you have this additional powerful tool that you can use if you use properly, and if you have to be careful with how you use it, because computational methods are dependent on how you model the structure, how you build them, what are the assumptions that you make in making that model. So similarly with machine learning, if you have the right data, if you have high quality data, then you're going to get a very nice machine learning model that you can use to maybe speed up your calculations as opposed to having to go through the traditional path. That said, garbage in, garbage out, right? So if you don't have the right model, then you're not going to have good results. And therefore, I don't think AI is going to replace existing, especially in engineering. It's kind of complemented. It's just an additional tool that if we know how to use it, and we know how to use it in a informed way, then it could be very powerful, because yes, it can help save us some complexity and some analysis tools maybe that may not be possible before. Now, in terms of jobs, I think it's important for the generation that's graduating now, and especially for those that are already in the workforce and they evolve, as they evolve in their careers, to be familiar with these tools, because again, they're going to be there for you to use them. And I think the job market is not necessarily going to shift to eliminating jobs. It's just going to be more leveraging people who can use these tools better. So I don't think it's going to replace anything per se. It's not going to eliminate anything. It's just going to be a change in how we approach solutions to certain problems. I'll give you an example of how my limited exploration of AI or machine learning went. So before I joined here, I was at Southwest Research Institute in Texas for 3 years, and there was a lot of interest in machine learning methods, obviously, because in industry, the appeal of having something that computes your solution very quickly is very, very attractive, right? But the problem for us in engineering is we don't have a lot of data, right? So if you think about how much data we get in terms of structural behavior, we get that from experiments in the lab, but those are very expensive and the results are very limited. So we don't have a lot of data that we can use to train a machine learning algorithm properly. And even with the data that we have, if we train that algorithm has no idea about the physics behind the problem.
Yeah.
So in some fields, maybe that may not necessarily be an issue, but for us, we are tied by the laws of physics. So if you predict stress and strain in a specific structure, those two have to be related to each other in a specific way, and if they're not, then that's not a valid prediction.
Yeah.
So we tried using AI machine learning methods. It turned out, you can really easily trick it to give you very bad results, and therefore you have to be very careful in how you approach this problem. I ended up doing something that's called physics-informed machine learning, meaning we basically built in the physics knowledge into the machine learning algorithm, which helped tremendously. But that means that you cannot just completely replace what we know as our physics-based models with the AI models.
About the data, so for like researchers or like structural engineers around the world, is there like a database of data for, perhaps building failures or experimental failures, and is that like easy to access and like useful data?
Unfortunately not. So there is a lot of data around the world, but it's not organized in a centralized location that everybody can access to, and that's one of the main challenges in research. That you go into literature, you find a paper, you may potentially be able to contact the authors and ask for the source data, and sometimes people are helpful and they give you that information, but that's not necessarily always the case. There is not a single place where you can go and access everything. Now, journals have been trying to address that, so now some journals will require you to submit your source data with your article, but that's still not organized in a way that is across the board. So you get different data structures in different formats, and that's not going to be conducive to any kind of search or anything like that. So unfortunately, it's not as organized as it could have been.
Okay, we're getting a little bit long, so I'd like to close out with some more, I guess, easygoing questions.
Yeah.
So how do you enjoy spending your time outside of being a professor?
Well, there's a few things that I do for fun. So I'm getting back into biking. So that's something that I used to do at Champaign-Urbana when I was a student. I stopped doing it for a few years, but now I'm trying to get back into it. And there's the obvious challenge that we're not in Champaign-Urbana. I don't know if you're familiar with Champaign-Urbana.
I'm not.
Very flat. So there's an obvious challenge here with, the hills, and that's been definitely a learning curve. But mostly exercise a little bit. I like to do yoga and a lot of Netflix. And
do you have any favorite series or movies?
Ooh, series. I am currently watching, this is a relatively older series that I don't know if you're familiar with it. It's called Monk. It's a detective.
I think I've heard of it. Yeah.
So that's the one that I'm currently watching. I'm almost like halfway through and I'm enjoying it quite a bit. it has a bit of this detective approach. I mean, obviously, it's a fun show too, and he has a very like distinct personality that kind of it's a fun series to watch. That's the one that I'm currently watching. But yeah, no, I enjoy quite a variety of movies and shows and
So we'll just end with this one. When you're not working, how often are you thinking about your field of research?
I try not to too much. It's sometimes it's important to disconnect, right? So you want to make sure that you have that time where you're disconnecting from your work. That said, because my work is kind of my own business in a way, so there's this constant thinking about, okay, what was going to be the next step, what am I going to do with this part or that part. So there's a bit of that kind of infiltrates my free time, but it's also good to do that when you're more relaxed and you're kind of some of the best ideas come to you at a very unexpected time. So I try not to limit it too much, but also I want to make sure that I get my time to disconnect from work, because that's also important.
I definitely agree. Actually, I think I'd like to end with a more useful question. Well, not that wasn't useful, but if you had to give some advice to an undergraduate student that's considering getting either a master's degree or a PhD and becoming a professor,
yes,
what pieces of advice would you give them?
Make use of your graduate program as much as possible. You want to make sure that you find the graduate program that's the best fit for you and for your interests, and keep in mind that your interests may evolve. When I started my master's degree, I thought I was going to do earthwork engineering, and the more you learn, the more you realize that maybe not this, maybe that. So keep an open mind, but definitely look for a graduate program that seems like a good fit to your interests. Now, being in a good program is important, but it's even more important that you have the right fit in terms of interests. So especially as you go forward with the PhD, and this is going to be a topic you're going to be working on for years.
Yeah.
So if it's not something that you're passionate about, it's not going to work out. So follow your heart. Make sure that it's something that you're really passionate about, and if you are, it's something that's going to be very rewarding, because for me, it's not a job anymore, and that stopped being a job a long time ago. It's something that I enjoy. It's something that I take very much pride in, and that also involves, teaching that to my students and making sure so that they are on the right track. So you want to make sure, again, that you have this right fit with a potential advisor and that you're happy with, the whole setup. So I highly recommend it. I would say at least a master's degree, because bachelor's is great, and I understand, the wanting to get into the job market as soon as possible. But I think a master's degree gives you a much wider education and gives you a little bit more insight into topics that maybe will be very helpful to you as you go down the line. But if you do decide to do a PhD and go into academia, make sure that you follow your passion, something that you are very enjoy doing and that you care about very much.
Okay, that's I think that was good.
Thank you. That was fun.